Continuing on in our notes, let's talk about how we do the opposite of writing those fractions as decimals. Here we're going to look at writing decimal numbers as fractions. So if your decimal is a terminating decimal or repeating, we're going to look at how we identify whether it is either. So for a terminating decimal, and I'm going to give an example here. A terminating decimal, I'm just going to use 2/10, we'll say. And we know that we can simplify that to 1/5, but I'm going to leave it as 2/10. So now if we read that correctly, so rather than saying 2/10, we would specifically say 2/10. We can figure out what that is as a decimal based on how we say it. So we first identify the smallest place value, and that determines our denominator. Of the fraction, and then the digits to the right of the decimal are the numerator of the fraction. So let's take 2/10 as that decimal. So like I said, rather than saying 0.2, we would actually say the correct way to read it, which would be 2/10. And the 2 is the numerator, where the place value, the tenths place, is the denominator. So those two would be equivalent. And we can say that fraction when we say the decimal correctly. And then we have these repeating decimals. And this is new information, as we have not spent any time writing repeating decimals as fractions. This year we only focused on writing terminating decimals as fractions. So let's think about the kinds of fractions that repeat. I think we can all think of some. We know that 1/3 repeats, therefore 2/3 would repeat. And if we think about 1/3 and 2/3, we know that 1/3 is actually equivalent to 3/9, and 2/3 is equivalent to 6/9. So just those two alone, we know repeat. Ultimately, we kind of have a rule for fractions that repeat. And any fraction that has a 9 or a 99 or a 999 in the denominator are fractions that repeat. And we also have two other numbers that are guaranteed to be decimals that repeat, and those are 7 and 11. So right now, before we go on to this next step where I show you the algebraic way to write these fractions as decimals, I'd like you to take the fraction, I don't know, using 7 or 11 as the denominator, so 2/7. And I'd like you to figure out what 2/7 is as a decimal. So right now you're figuring out what 2/7 is as a decimal. So as we can see here, it comes out to be 0.2857, and then there's another series of numbers. And while we can't tell where it repeats, because I just used my calculator for that, it does end up repeating. It's just a longer series of digits that repeat. So now let's look at how do we algebraically turn a fraction into a decimal. So I am going to take and just use 0.4 repeating. So we're going to write a fraction as a decimal. So we've got this decimal 4/10 repeating, so 0.4 repeating. I'm going to use an equation here, so I'm going to let n equal that number I just made up, 0.4 repeating. So n is equal to 0.4 repeating. So now, thinking about this, what would 10n equal? Well, to find that out, I'm going to multiply both sides by 10. So I'm going to take 10 times n, which would be 10n, and I'm going to take 0.4 repeating, times 10, and we know that when we multiply it by 10, the decimal point just moves over one place. So now it becomes 4.4 repeating. So 10n is equal to 4.4, and then we have that fraction bar, or the repeating decimal sign above the 4. So 4.4 repeating. So 10n equals 4.4 repeating. Well, what I'm going to do is solve for n, and n is going to be the fraction that 0.4 repeating represents. So just like a one-step equation, 10n equals 4.4 repeating, I'm going to solve for n. But the first thing I'm going to do is I'm going to take away n. So take away 1n, and we know that 1n is 0.4 repeating. So on this side, I'm going to take away 0.4 repeating. So I'm left with 9n equals 4. And to get n by itself, I'm going to divide by 9 and divide by 9. Therefore, n is equal to 4 divided by 9, which is 4/9. So as we can see, n, which we stated above was equal to 0.4 repeating, it is also 4/9. So 0.49 as a fraction, excuse me, 0.4 repeating as a fraction is 4/9. Now, we don't have to do that specific process every single time. Ultimately, what I just showed you is that in order to get a repeating decimal, the fraction can be written with digits of 9, and it can. So keyword that if we can just identify, then we know that that's what the fraction would be. And it can be written with digits of 9 in the denominator. So if there's one digit that repeats, the fraction will be the digit that repeats over 1/9. So again, looking at what I just showed you, 0.4 repeating, just the 4 is repeating, therefore it's just one digit, so it's written as a fraction over 9. If there are two digits that repeat, the fraction will be written with the digits that repeat over 2 9s, which would be 99. So for example, if I have a fraction that is 0.23 repeating. Well, 0.23 repeating, that's 2 digits that are repeating. It's 2323. Therefore, that fraction here would be 23 over 99. So here ends page 2 of your notes. Before going on, using this little part, at the bottom of the page that we just talked about, that trick over what the denominator is based on how many digits are repeating in the decimal, I encourage you to pick another series of 2 digits that would be a repeating decimal, and then write that as the fraction, and then check it. So just like this, where I had 0.23 repeating, and that it would be 23/99, pick another, so make it up, right? 0.45 or something. And then write the fraction that would be for that repeating decimal, and then check it. Because remember, we know how to convert this fraction to a decimal by taking 23 divided by 99. So do the same with yours before going on to page 3.